yeah, we want to believe. We really want to believe, just like the X-Files. But eventually, when nature tells us otherwise, we throw out those beliefs like yesterday's newspaper. That's why science is so neat.
Now, people that are listening to this are probably going, what is gauge symmetry, dude? You just passed over that, and you said it was crazy.
Okay,
is there a way that you could possibly just give
I'll try.
a synopsis?
Sure,
Okay.
we'll try. We'll see how we do.
Okay.
So it turns out that there's a fundamental principle in nature which really was discovered by this wonderful woman mathematician, Emmy Noether, who wasn't even allowed to get a job because she was a woman at the turn of the century. But she discovered, so there's things we say, and we tell kids, unfortunately, in schools, energy is conserved and momentum is conserved. It sounds like the Ten Commandments, like we come up with them because we like them. And now we understand them differently. We understand that everything that is conserved, that doesn't change in the world, is due to a fundamental symmetry of nature. So energy is conserved because we now understand the laws of physics don't change over time. So as long as you can test that the laws of physics are the same tomorrow as they are today, then we know energy is conserved. It's not something we take on faith. It's a mathematical consequence of that. Momentum conservation is a consequence of the fact that the laws of physics don't change from place to place, that they're the same in this studio here as they would be if we were having this conversation in New York. That seems reasonable, and she showed mathematically it's the case. So there's a famous, everyone's experienced this who learned any physics, conservation of charge. You know, the electric charge in any system doesn't change magically over time. That's a fundamental property of electricity and magnetism. You got a certain amount of charge at the beginning, it's got to be the same at the end. That's a consequence of the fact that it's arbitrary. There's a symmetry of nature that says, Benjamin Franklin called electrons, negatively charged. But it doesn't mean anything because I could have called them positively charged. It's just an arbitrary definition. If I changed every negative charge in the world to positive charge and every positive charge to negative charge, everything would work the same way. A symmetry of nature represents something that doesn't change about nature when you make a change in a definition. So calling electrons positively charged and protons negatively charged would not make the world difference. It's an arbitrary name. Martians could call electrons positively charged and protons negatively charged. There's nothing fundamentally important about the word positive charge. It doesn't mean any different than a negative charge. So I could change right now, I could make I could change the charge on every electron in the universe and flip its sign. So every electron is negatively charged now, but now suddenly I'm God and I make every electron positively charged and I make every proton negatively charged. Nothing about the laws of physics will change.
I don't understand that. Why wouldn't it change? I mean, is there a function of them being positive or negatively charged?
No, it's just a name. That's why it's like calling. I could call up down and down up, and it wouldn't make it.
As long as it's a noise you make with your mouth.
Yeah, exactly.
Right, okay.
So the name I give it is irrelevant.
Okay, so it's not like you would change the actual function of the electron.
No, exactly. I call it's electrically charged. That's important.
Okay,
and it repels other electrons because they have the same electric charge. That's important, right? Two electrically negative charged particles repel.
Right.
But look, if I made them both two positive charged particles, they'd also repel. So the physical consequences would not change at all depending upon how I named them.